So in section 4.1, we are going to be looking at exponential functions. And an exponential function has the form f of x is a to the x or b to the x or whatever. It's just your unknown is in the exponent. That's what an exponential function is. They're a little different in the fact that your base doesn't change, but your exponent does. So here's an example of an exponential function. Again, your x is the exponent. So if I wanted to find f of 2, 2 would go in for the exponent. 2 squared would be 4. If I wanted to find f of negative 2, it would be 2 raised to the negative 2 power to get 0.25. So, what you need to be concerned with is, do you know how to get these on your calculator? Okay, so if you don't have your calculator as you're watching, you may want to pause the video and go get it so you can work some of these with me just to make sure you're typing in the correct functions. Okay. So for the first example, I got f of x is 3 to the x power, and I want to evaluate. So f of 2 would be 3 squared, and f of 2 would be 9. I think probably most of us are okay with that one. Now, the issues become when you're doing fractional exponents or symbol exponents or square root, things like that can get kind of tricky typing them in. So if I want to find f of negative 2/3, well, it is 3 raised to the negative 2/3 power. Now, what you've got to do is you've got to type in this exponent. And more than likely, most of your calculators have that button right there. And then you've got to put inside parentheses the negative 2 divided by 3. Okay, so again, it all depends upon the calculator you have. And your functions. Now, what you can always do in class is, you can ask me, and, I'll show you. So it's okay if you don't have it right now. I can show it to you when you get to class, but you should get about 0.48, roughly. Okay, now you may have a Y to the X button, whatever button you use to raise, do different exponent other than squaring is what you've got to use. Now, f of pi is 3 raised to pi. Now, most of you all have a pi button on your calculator. You can certainly use that, or you can use 3.14 for pi. So either way is fine. Either way is fine. Okay. Got to watch my brightness here. And you should get 31.5 roughly. Now, the last one, the f of the square root of 2, it's a little bit tricky simply because, you can type it in as 3 raised and then in parentheses square root of 2. You can pull that up on your calculator, or you can make the square root of 2 a decimal. So you could certainly, find the square root of 2 first, which is 1.41, and do it that way. Okay, so those are your choices. And that's 4.71. I'm running out of room there, so I'm just going to write it right off to the side there. So that's one thing we will be doing with exponential functions. We will be evaluating. The other items will be graphs. Exponential functions, they have curves, okay, because as x gets bigger, y gets bigger really quick when your base is bigger than 1. So if you can imagine 2 squared is 4, 2 cubed is 8. 2 to the 4th power is 16. So you can see the gap in between each value of y when I change x gets bigger and bigger. So therefore, it grows faster and faster. Now, this graph here illustrates kind of the opposite of that. So when your base is like a fraction, like 1/2, 2/3, 1/3, it's positive, bigger than 0, but less than 1. What's going to happen is as x gets bigger, y gets smaller. Again, if you took 1/2 to the 1st power, you get 1/2. Well, if I take 1/2 to the 2nd power, I get 1/4. So that's smaller than 1/2. So that's what this illustrates here. What you've got to remember for graphing is which shape you're choosing. The best way to do it is to realize if your base is bigger than 1, it's this one. If it's smaller than 1, it's this one. And both of these from the start have a y-intercept, and I have no idea why this thing keeps doing this to me, of 1. Okay, so remember that when we graph, because we're going to graph these by shifting. So let's look at that. It's got to be a focus thing. That's probably why this is going. So let me see if I can darken it up. Maybe that'll stop some of it. I don't know. All right. So when we graph these functions, we're going to use transformations as we did back in section 2.5. Vertical shifts are going to look like your base to the exponent plus some number or base to the exponent minus some number. Horizontal shifts are going to be where you're subtracting or adding in the exponent. So the same principles apply as when we did shifting back in chapter 2. Horizontal shifts are opposite the sign. Vertical shifts are with the sign. So if I look at 3 raised to the x minus 1 power, this is a horizontal shift 1 unit right. Opposite the sign. So the graph I'm starting with is this one, because my base is 3, which is bigger than 1. And what I'm going to do is I always shift the y-intercept. That's, to me, the easiest way to do this is to move your y-intercept and re-sketch it. So what I'm going to do is I'm going to move the y-intercept. Instead of being here, I'm going to move it there and then sketch it. Okay, it's just a sketch. Just remember it's got a curve. Don't make a straight line. And we have a horizontal asymptote at y equals 0. The other possibility is different base, and this is a vertical shift. So this is a vertical shift down 1 unit. So I'm going to be using this shape because my base is 1/3, which is between 0 and 1, and I'm going to shift this down 1 unit. My horizontal asymptote will shift down 1 unit. So I just relocate the y-intercept. If it helps, you can kind of sketch your horizontal asymptote and then just sketch it. You know, if I can draw it, anybody can draw it. So it borders the horizontal asymptote. And it actually does go through the 0, 0 point there. That's my bad. I tried to talk and draw, so I only have so much ability in my right hand. And that's it. No need to create a table of values. I mean, we're just going to use transformations to graph these. So it may take a little bit. I mean, I'm not saying this is easy, but that's all we're doing with it, okay? The other type of exponential function involves a function which uses e as its base. So I've got an old calculator here at my house, but let me see if I can find it. So if you look on your calculator, and most of your calculators are going to be the same, you've got a e to the x button that's associated with the ln button. Okay, that's what we're talking about. It's a number like pi that's used in many different types of formulas, so it has its own button. Okay, so if I want to evaluate e cubed, and again, depending upon your calculator, you know how to access it, that may be the biggest problem. Like for this calculator here, I've got to actually type in my exponent first and then press my second function ln, and I get 20.09 or 20.1. For other calculators, you can locate the e to the x function, like if you have a graphing calculator, pull it up and then type in your exponent. So it all depends. So, you know, if you have trouble, again, just see me and we'll talk about it in class. Right here, this involves 2e to the negative 0.53. So if your calculator allows you to type in your e to the exponent, then you type 2, pull up your e function, type in your exponent. For a calculator like this, I got to do it backwards. So I put in 0.53, I make it negative, hit my e function, and that's 0.588, and then I've got to multiply it by 2. So I got to kind of work almost or do everything backwards with this one. So it's 1.18. Then e to the 4.8. So again, this calculator, I type in the exponent, second function, and I get 121.5. Okay, so I'm going to give you a second or two just to make sure that you're good getting those. All right, well, now let's look at the graphs, okay, because the graphs are very similar to the exponential function where your base is bigger than 1 because e is bigger than 1. So it's the same exact graph as a y-intercept of 1, horizontal asymptote of y is 0 to start off with. And if I wanted to graph e to the x minus 2, that is a vertical shift down 2. So I'm telling you, the best way to do it is to move the y-intercept, shift it, shift your horizontal asymptote, and then sketch it. Okay, and so to me, that's really the easiest way to do it. And some of y'all will have trouble with this. It's okay. We'll be doing more practice, and you'll get the hang of it. Okay, but that's it on exponential functions. So we will pick up from here.